Guys, today I'm back with the 062532 actually. So this was the one that we did in the last video. Not in the last video, this is just a new question paper. As you know, I'm doing question by question, and therefore is my first video on this paper. Okay, so this is the first question, which is usually extremely simple, and people must be able to solve it. It's usually about speed, velocity, acceleration, all of that things. So, okay. Know why I'm dropping text boxes all over the place. Yep, that's nice. Alright. The tank is 51 meters long, which means that this is 51 meters from here to here. 51 meters long. And yeah, the first question is usually about velocity or density, and it's 20 meters wide. The seawater in the tank is 11 meters deep and has a density of 1030 kilogram per meter cubic. Calculate the mass of the water. So what's the volume? First we have to divide it. We have to multiply the volume by the density, right? So we just have to obtain the volume, which by the three measurements, 51 into 20 into 11 is the volume, into multiplied by 1030, which is the density. We just get the mass as I don't think it's so large actually. Yeah, it is large because usually it's not like 51 meters. It's only a few meters actually. So that's supposed to be a huge tank. It looks like. So that will be 1,155,6,600 kilograms. The pressure at point P, which is here, is point P. Point M, sorry, measured halfway down the large viewing panel here is 60 kilopascals more than atmospheric pressure. So rho GH is equal to 60 kilopascals. So maybe I'll just do this with math type. Math type. And then just turning on. Don't send. Continue trial. Don't send. Let me just try to where's the row sign? Statistics, tab 8, tab 9. Where's the row sign? I don't know. Somewhere here? No, not there. Okay. Ah, yes, there it is. So where is the row? Row is there. So row is there, right? This MDA. Yeah, so here you have slash here, so row. Just copy this and then let me just try to paste it in here. I'm not very sure whether it's possible, but it must be possible actually. Let me just try to paste it there. No, it's not possible. So okay, so let me just put in uh Yeah, I'm sorry. So rho g h, or let me just call it density, multiplied by d multiplied by h is equal to 60,000. Now you have d, density is 1030, right? 1030 into g, which is 10, into h, which is we don't know, but 60,000. H is equal to, simple, just calculate it with using your calculator, 60,000 divided by 10300, 5.83 meters. So H is 5.83 meters. Yep, okay. The viewing panel is 3 to 32.8 meters wide and 80.3 meter high. Calculate the upward force of the water on the panel. Assume that all the pressure at M is the average pressure on the whole panel. So pressure is equal to force per area. So you have got the pressure. If you multiply it by area, you must get the force. So the pressure, you must remember to keep in the exact value. You can store it on your calculator. Okay, so just multiply your answer, the exact value, which is 5.8252427 something. So 328 into, just multiply your answer by 32.8 and 8.3. So you get 1585 something. So just write it to how many ever significant figures you like, but it's better to be in three significant figures. 1590 newtons. So that's correct. So we'll check out. This is one much. This was totally calculation, as you can see, and they're giving out a whole 7 marks for calculation. Note that if you just write this answer as it is, you still get the whole mark. So doing the steps is worse. So I've got the maximum open as well. You see that's M marks, a method marks. Yeah, there's somewhere it's written somewhere. Calculation question, significant figures. Yes, answers are normally given acceptable to any significant figures. For example, 2. Accept answers that round to give the correct answer to 2 significant figures. Any exceptions to the general rule will be specified in the mark scheme. So yeah, so arithmetic errors. If the only error is arithmetic transcription. So if you read through this whole part, somewhere it's there. I've read through the whole thing, but it is, yeah, okay, I think it's here. There are compensatory marks. These can be scored even if the point to which they refer are not written down by the candidate, provided subsequent working gives evidence that they must have known it. For example, an equation carries a C mark and a candidate does not write down the actual equation but does correct substitution or working which shows he knew the equation, then the C mark is scored. A C mark is not awarded if a candidate makes 2 points which contradict each other. Contradict means you say that happens and the next sentence you say that does not happen. So in any form, words or symbols anyhow. So you get 1.2 approximately. Yes, 1.2. We wrote more exactly. It's a 2 significant figures they have given us. But we wrote up to how many? 1, 2, 3, 4, 5, 6, 7, 8, 6 significant figures. So you have 5.83 meters, okay, and 1.63, hey, 60,000 times 32.8. What? 60,000. Oh, oh yeah, you are not supposed to multiply by the depth, so our answer is wrong actually. So I'm sorry guys, you're not supposed to multiply by the depth. Instead, you're supposed to multiply by the force here, this force, this pressure actually. I'm trying to just multiply by force, 60,000 delete. So that'll give you about 16 megapascal or 16,000 kPa. Oh, sorry, not sorry, 16 about 16,000 kilonewtons. Yeah, there. I'm sorry. So okay, so next one we'll look in the next video. And yeah, of course, that's about extension and load. This is a very important question. Well, it may or may not be that hard, but it surely is there in almost every examination.